Bem-vindos ao nosso espaço, um mergulho profundo nos assuntos mais interessantes de esportes, ciências e temas gerais do momento. Aqui você vai encontrar conteúdo de qualidade, com análises empolgantes e descobertas fascinantes que vão expandir seus horizontes. Nossa missão é trazer informação relevante de forma dinâmica e descontraída. Queremos que você faça parte dessa jornada incrível de conhecimento e diversão. Se gostar do nosso conteúdo, não esqueça de deixar seu like e se inscrever no canal para não perder nenhuma novidade. Ative o sininho também. Aproveite!
If you love science, don't forget to like and subscribe. Imagine possessing a sense so precise it allows you to visualize temperature differences as a three-dimensional map. A world rendered in contours of warmth and cold. For pit vipers, a diverse family including rattlesnakes, copperheads, and cottonmouths, this isn't fiction. It's the reality of their existence, dictated by a remarkable biological apparatus, the pit organ. This isn't just seeing heat, it's interpreting the infrared dialect to construct thermal geometry. To understand this, we must first appreciate the biology. The pit organ is a deep sensory cavity located on either side of the snake's head, positioned strategically between the eye and the nostril. But this isn't just an empty hole. It's lined with a delicate, highly vascularized membrane, rich in specialized nerve endings. This membrane acts like the film in an old camera, but instead of detecting visible light photons, it detects electromagnetic radiation in the infrared spectrum, the heat emitted by warm-blooded creatures. The genius lies in the structure itself. The pit acts like a pinhole camera. Infrared radiation from a nearby object enters the opening and strikes the back of the membrane. Because the opening is small, only heat coming from specific angles reaches specific points on the membrane. This spatial differentiation is crucial. It allows the snake to build a highly accurate, topographic map of the heat source's location, size, and distance, a true thermal geometry. Unlike traditional visual perception, which relies on interpreting reflected light, thermoreception is a direct reading of emitted energy. Every object above absolute zero radiates heat. A field mouse, even on the coldest night, is a glowing beacon of infrared energy. The snake isn't just sensing that something is warm, it is interpreting the geometry of that warmth. For instance, a small, continuous heat source is read differently than a large, complex heat source, allowing the snake to discern the difference between a rock warmed by the sun and a breathing, moving rodent. The sensitivity is staggering. Pit vipers can detect temperature differences as slight as 0.003 degrees Celsius. This hypersensitivity is what allows them to achieve their legendary striking precision. In absolute darkness, relying solely on this thermal geometry, they can calculate the precise trajectory and required force to hit a vulnerable spot on their prey, ensuring a successful, and often fatal, envenomation. Crucially, the snake's brain performs a fascinating feat of integration. The visual cortex, which processes optical information, shares processing space with the thermal sensory system. The snake's mind effectively merges the two inputs. By day, they utilize standard vision combined with thermal data to refine depth perception and detect camouflaged prey. By night, when optical information fades, the thermal map takes over entirely. This dual sensory system ensures 24/7 hunting efficacy. The term dialect is used because this infrared sensing extends beyond mere predatory function. It's a communication tool, albeit a subtle and often passive one. While snakes don't actively transmit infrared signals to communicate complex messages, they constantly receive them. They can sense the presence of conspecifics, other snakes, through their thermal signatures, aiding in mate location or, conversely, avoidance of rivals. Furthermore, the dialect includes environmental mapping. Snakes are ectotherms, relying on external sources for heat regulation. Their ability to precisely map the thermal contours of their environment, identifying the warmest basking rock or the coolest, most sheltered crevice, is vital for survival and metabolic function. They navigate a complex, invisible world of thermal opportunities and threats. In essence, the pit viper lives in a state of perpetual thermal awareness. Its world is painted not just in color and shadow, but in the intensity and geometry of heat radiating off every molecule. This adaptation didn't evolve by chance. It is a perfect solution to the challenge of hunting endothermic prey in environments where darkness or heavy cover makes visual tracking impossible. The pit organ transforms the heat of life into a lethal, geometric map, allowing these ancient predators to thrive in the dark corners of the world. For more incredible facts like this, don't forget to subscribe and turn on notifications.